Abby and Alex, how are you all doing this week? So we're going to move on in to our usage of integrals. So what we're going to be talking about this week is a definite integral. So this is where an integral really comes into play. Nobody's ever going to ask you to really just do an integral and let it sit there. These definite integrals are the useful ones. Okay, so these are what we will use here coming up to start finding areas under curves. Okay, so this is called the fundamental theorem of calculus. We'll commonly refer to it as definite integrals. So basically, take a look at my formula that I've put out here. We're going to see an integral from a to b. Okay, so that's what this formula that I have right here. That says the integral from a to b of f of x dx, okay, is equal to, these guys right here are integrated already. Okay, those have already been integrated. Okay, so that's the integral of b minus the integral of a. So basically, what we're going to do is we're going to take the integral, we're going to plug b in, then we'll subtract, plug an a in. Okay, so it is not that bad. We should be able to get it done here. Let's take a look at example 1. First thing we've got to do is integrate our problem, so we need to really just disregard the 1 and the 2 for a few minutes. If you remember back to our integration rules, we add 1 to the exponent and then divide by that number. So on x squared here, we'll add 1 to the exponent, that makes it x cubed, and we'll divide by that number. So basically, we had been writing it as this, 1/3 x cubed. So then on a whole number, we just have to add an x, so we'll have minus 3x. So we have successfully integrated that problem. Okay, now it's no longer an integral, so I cannot put the big S out front. So what I'm going to do now is I'm going to use this bracket. This is what I use after I've already taken the integral, and I'm going to use my 1 and my 2 out to the side. Okay, so this is how it works. Moving forward, what we've got to do, we're going to take our 2 and plug it into the function. So I've got 2 cubed. Let me grab a calculator. Hang on. Alright, so I've got 2 cubed, which is 8, and then we're going to have 8 times a third. We'll just call it 8/3. Guess I really didn't need the calculator for that. So this is plugging, let me make a little note here. Plug 2 in. Alright, that's what we're doing here. So we've got 8/3 in the first set. I got 3 times 2 in the second here, so that's minus 6. So 8/3 minus 6, let's go ahead and get a fraction for that. 8/3 minus 6 is negative 10/3. Okay, so that is negative 10/3. So that is, up here in my formula, this f of b, plugging b in. Okay, so I've taken the integral, I've plugged in the top number. Okay, that's what I got for the top number. Let's not forget it. Now I've got to plug in the bottom number. Plugging 1 in, 1 cubed is 1. 1 times a third would be a third. And then I've got to subtract 3 times 1, which would be 3. So if we want to get a number, it should be negative 5/3. 1/3 minus 3, negative 8/3, sorry. Okay, so now, once I've come up with this is my bottom number. And remember, the formula up here says f of b minus f of a. So this one right here, let me make a note. This is f of b. This is f of a. And the formula says to subtract them. So what I really need to do here is negative 10/3 minus negative 8/3, which would be adding. Okay, and if I add those up, I get negative 2/3. So that definite integral equals negative 2/3. That is a whole number, or well, not a whole number. That is a numeric answer that we will put here. We don't have any x's or anything in it. Okay, so this problem really is not bad. Let me recap it one more time what we did. We took the integral to get to here. We used the bracket form because we no longer had an integral to get it, because we no longer could put the s out front. Then all we had to do was plug in the top number, get that, and then subtract whatever we got when we plug in the bottom number. So top number being 2, bottom number being 1. Let's take a look at the next one. I'm going to rewrite this one because it is not in a form that's very easy to use right now. If you remember one of the rules, a whole number that you have is allowed to come out front. So I'm going to rewrite this as 3, and then I'm going to bring my integral. And then I've got the square root of x, which is x to the 1/2. okay? Oh, by the way, notice we didn't put any plus c over here. That's because this is a definite integral, and we would have to know what that c is. So we're just assuming that there was no c in this kind of problem. I'm going to integrate this, x to the 1/2. That means add 1 to the exponent and then divide by that number. So adding 1 to that would be 3/2. So x to the 3/2 and then divided by 3/2. If you want to think about that over here at the side, x to the 3/2 over 1 divided by 3 over 2. If you repeat, change, flip. Okay, this is really going to be 2x to the 3/2 over 3. Okay, so that's what we get when we integrated it. Don't forget, we still had a 3. So if you want to multiply the 3 back in, that would be great. They cancel out, so we've really just got 2x to the 3/2. But now we have to take into consideration our numbers that we're doing. So we're going from 1 to 4. So I'll plug in the top number. So I've got to do 4 to the power of 3/2, which is 8. And then multiply that by 2, so I get 16 for the top one. And then I'm subtracting what I get when I plug in the bottom one. So 1 to the 3/2 is obviously going to be 1. And, 1 times 2 would be 2. So we got 2 here. 16 minus 2 gives me 14. So that definite integral outputs us 14. All right, so highlight that process one more time. We took the integral. The reason I canceled the 3 is because I had it hanging out front, had to multiply it back in. So then the integral really was just 2x to the 3/2. I plugged in 4, got that number. Plugged in 1, got that number, and subtracted them. So 16 minus 2 is 14. Let's move down here and take a look at a trig one. All right, so I've got secant squared x dx. Okay, I've got to integrate secant squared x. If you remember back when we talked about the integration rules, there is an integral of secant squared. It's actually tangent, okay, because the derivative of tangent was secant squared, okay? So this one is actually pretty easy because we can just call it tangent. So the integral is tangent x, and we'll be doing that from 0 to pi over 4, okay? So now I just got to plug in pi over 4. Tangent at pi over 4 is actually 1, and then tangent of 0 is actually 0. Okay, so this one was actually pretty easy. Now put us on 1. So these tangent ones, these trig ones are always going to work out like this, where you've got something that just kind of, it's the opposite of the derivative, if you remember that. Okay, so they're really not that complex. Just plug them in. I know these things from the unit circle, but you can plug them into the calculator and it'll give you the same thing. Okay. One more. We've got an absolute value one. So this one gets tricky. Okay, because the thing about an absolute value is this graph actually looks something, that's a pitiful looking coordinate plane. This graph actually looks something like this. Okay. So what we have going is 2 different lines. And if you remember about an absolute value, what's really going on is 2x minus 1 is really like saying you got, you got negative 2x minus 1, which would be this line coming down, okay? But you also got regular 2x minus 1, which would be this line going up, okay? So we have to take both of those into consideration, but what we need to understand is, what we need to figure out is what this turning point is right here. So we need to know where that location is. It's actually very easy to find. All we've got to do is set 2x minus 1 equal to 0. So I'll add the 1 over, divide by 2. So x is 1/2. Okay, so basically the top graph exists before 1/2. Okay, so when x is less than 1/2. The bottom graph exists when x is bigger than 1/2. Okay, so we can call one of them equal to. It doesn't really matter. Okay, so here's what we've got to set up. What's really going on here is I'm not doing the integral from 0 to 2. I'm doing the integral, whoa, hang on. I'm doing the integral from 0 to 1/2 of the negative graph, negative 2x minus 1, And then I'm also doing the integral from 1/2 all the way up to 2 of the positive graph. So regular 2x minus 1, okay? This was part of the side. This is what I've got to do on an absolute value situation because I really have two different lines that I'm talking about, okay? So hopefully that did not confuse you too much. This is really negative 2x plus 1 if you want to think about it like that. That's going to be way easier on us. So let's integrate. I got to add 1 to the exponent and divide by it. So adding 1 to the exponent here on negative 2x would be negative 2x squared divided by 2. This is going away, right? So I got negative x squared, and then I got a 1, so that's adding an x. Okay, I took the integral, so I'll use my bracket instead. Okay, so I've got to figure out that. Then I've got to integrate the second half, 2x. It's going to be the same, just without a negative, so we'll have x squared. And I got minus 1, which would be minus x. And that's going on from 1/2 all the way up to 2. Let's plug in some numbers here now. Plugging in a half. That should give me, so 1/2 to squared would be a fourth, so negative 1/4, and then plus a half, okay, and then, so that's the top, and then minus, plugging in the zeros would be 0, right? So I've just got to figure out what negative 1/4 plus a half is, which is a fourth, okay? So then that's the whole left side. Let's figure out the right side. Plugging in a half, I'm sorry, I got to plug in the top number. Plugging in a 2, that would be 2 squared is 4 minus 2. So this is going to output me 2 here. And then I got a minus, plugging in the bottom. So 1/2 squared would be a fourth minus a half. So 1/4 minus 1/2. That would be negative a fourth. So 2 minus negative 1/4. So adding, that'd be 2 1/4. So 9/4. So adding those together gives me 10/4, which reduces down to 5/2, which is our complete answer on this guy. All right, so remember, this is what you have to do in an absolute value situation because you really have two lines going on, okay? So overall, the process is not that bad. Integrate using your integration rules. If you forgot those, go back in the book and look them up. Integrate using your integration rules, and then plug in the top number, get that, and subtract whatever you get when you plug in the bottom number. So this is actually a very easy process. This is something that we will be using moving forward. It's very important to us. So make sure you get a good understanding of that. Here's the whole page if you need to take a picture of it or anything. Today, let's work on page 328, numbers 5 through 37 odd. All right. So you guys let me know if you have any questions. You've got my message. Just